Today's lesson, we're going to look at dependent and independent events in probability. So the learning goal covers through this in two-step probability events, and it could also be in three-step. We learn if they are independent of the first step. Now that's really important. Does the first step affect the second step? If it does, it's dependent. If it doesn't, it's independent. But like always, we're going to use examples to try flush this out. So 2 up, is it independent or dependent? So we looked at this in a previous video, and we go heads, tails, and remember there's 2 coins. First coin, and then there's the second coin. So these are coins, second coin, and that's heads, and that's tails, and that's heads, and that's tail. Now, this one is the first coin is independent of the second coin, because it doesn't matter if it lands on heads or tails. That does not affect the probability of the second coin. So is it independent or dependent? It's independent, because what happens in the first coin does not affect the probability of what happens in the second coin, and so on. We can do it again, and the first coin won't affect the probabilities of the second one. So these probabilities don't change in the second coin as opposed to the first coin. So it is independent. All right. What about a class raffle where 2 prizes are drawn? Now, I've done this in the past. Once I had these sunnies from the Philippines, okay, and I had 2 to give away. Okay, so what I did is I did a class raffle. Say there was 23 students in the raffle. What are the chances of getting the sunnies in the first round? Well, it will be 1 out of 23. Okay, what are the chances of not getting it? It'll be the rest, 22 out of 23. Okay, so that's sunnies, and this is no sunnies. Okay. Now, what I did in this class raffle is that one of the students won the prize, and then I said, "You're out." Okay, so sometimes we call this without replacement. So what happens is that I'm sending that student out, and they can't be in the draw for the second round because I said it's unfair that you have a second go at it because they've got a pair of sunnies. So in this second round, what are the chances of getting the sunnies? How many students are there now? Well, there's 1 less. So we almost have to make it out of 22. So to get the sunnies or no sunnies, all right, it's going to be 1 out of 22. And to get no sunnies will be 21 out of 22. Now notice here that the probabilities have changed. Okay, and they will change down here as well. Down here, we can get sunnies or no sunnies. I'm going to try to keep it consistent. Sunnies or no sunnies. All right. So the chances of getting sunnies are the same, 1 out of 22 or 21 out of 22. Okay. That was not what I intended to do. So these probabilities have changed from these probabilities. Notice that. Now, because of that, that means that it is dependent, right? Because it's dependent on what happens in the first round. So this second round is dependent on what happens in the first round. So is there something that happened before in the first round that affects the second round? That means that affects if it's dependent or independent. All right, last one. Rolling 2 die during Monopoly. So we actually had a look at this previously, what all the events are. And essentially, you roll 1 die, okay? And let's say, I don't know, let's make it easy. Rolling 1 die to get a 4, okay? What are the chances of getting a 4? Well, it's one number out of how many? 6. So that's getting a 4. What's the chances of not getting a 4? I spelt 4 wrong. I'll just write the number, because what's the chance of not getting a 4? Well, it's everything else. So it'll be 5 out of 6, because there's 5 numbers that aren't 4s. Okay. What about the second die? And we're going the same thing. We're trying to get another 4. Well, in that second die, does it matter what happens in the first die? No. So we've still got a 1 in 6 chance of getting a 4 and a 5 or 6 chance of getting not a 4. All right. And the same thing happens down here. What happens with the first die did not affect what happened with the second die. So that's a 4. I'm going to use a highlighter to change it. 4 or not 4. 4 or not 4. Okay. Now notice this, that these probabilities did not change, even though it was in the second round. So what do you think? Are they independent of the first round or dependent on what happens in the first round? I think most of you have got the answer that it is independent. Okay, so that's the end of that one. So that's independent or dependent events. Peace out.